Okay, common factoring. Looking for the greatest common factor. The greatest common factor is the largest factor you can divide all terms in a polynomial. The factor can be numbers, variables, or a combination of numbers and variables. In our first example, we're asked to find the greatest common factor of 12 and 9. On the left table, we've listed all the factors of 12, and on the right, we've listed the common factors of 9, and then highlighted the greatest common factor of the two, which is 3. In example B, we're asked to find the greatest common factor of 4 and 6. So we list all the factors of 4, all the factors of 6, compare the two charts or the two tables, and we can see that the greatest common factor in this case is 2. In example C, we're comparing x squared and x cubed, and we see that the greatest common factor of them happens to be x squared. Factor each of the following by indicating the greatest common factor. Well, we're looking at example 1, 3x squared plus 6x minus 36. So what number could we divide all three terms by evenly? So in this case, 3 is the largest that we can divide all three terms by. So we say our greatest common factor is 3. Now, once we've determined that the 3 is the greatest common factor, we divide the entire trinomial by the greatest common factor. And once we simplify that, we get 3 bracket x squared plus 2x minus 12. Now, if we want to check to see if we've done this correctly, we can work in reverse. We can simply expand what we have. So we take that 3x squared plus 2x minus 12 and expand it out, and we should arrive with our initial polynomial. If you look up at the top, you'll see that, yes, by expanding this, we did end up with 3x squared plus 6x minus 36. So we can be comfortable knowing that 3 bracket x squared plus 2x minus 12 is the correct answer. Here we are, example 2. 5x to the 5th plus 15x to the 3rd minus 35x to the 4th. Now we can see fairly readily that all of these would divide by 5, but there is more to it than this. Not only will they divide by 5, they will all divide by 5x to the 3rd. That is the greatest common factor. So we take that original trinomial, 5x to the 5th plus 15x to the 3rd minus 35x to the 4th, and we divide it by 5x to the 3rd. And when we do that, we have 5x to the 3rd, which is our greatest common factor, bracket x squared plus 3 minus 7x. Once again, we can check this by simply expanding it out again. And when we do that, 5x cubed times x squared gives us 5x to the 5th. 5x cubed times 3 gives us 15x to the 3rd, or 15x cubed. 5x cubed minus 7x gives us negative 35x to the fourth. So the fact that we arrive at the original question or the original polynomial shows us that we have done this correctly. So in each of these examples, we're asked to factor each by a common factor. 3x squared plus 21x plus 30 will all divide by 3. That's the greatest common factor. So we write 3 on the outside, then brackets, and then x squared plus 7x plus 10. For our next example, negative x squared plus 4x minus 3, the greatest common factor is negative 1. We put the negative 1 on the outside of the brackets, and then within the brackets, x squared is 4x plus 3. For the third example, our greatest common factor will be 3. Put the greatest common factor on the outside, write in our 3, bracket, x squared plus 7x plus 10. Next example, our greatest common factor is 4. Put the 4 on the outside of the brackets, and inside we have x squared minus 3x minus 18. Our next example, our greatest common factor is 2. 2 on the outside, bracket, x squared plus 2x plus 1. In our last example, our greatest common factor, it looks like it's 4. 4 on the outside, bracket x squared minus 3x minus 18. In these examples, we're told you can also have a binomial as a greatest common factor. So in looking at this first example, we can see that both of these terms can be divided by 2 plus a. So 2 plus a is our greatest common factor. We put our greatest common factor at the beginning, divide both terms by 2 plus a. The 2 plus a's cancel out, and we're left with 2 plus a times 2a minus 3. In our next example, our greatest common factor is x minus 2. Both of these terms will divide evenly by x minus 2. So that's our greatest common factor. So we put our greatest common factor in the front. We divide both terms by our greatest common factor. And then we can cancel out our x minus 2's, and we're left with x minus 2, 2 plus 3x.